And we are live.
Good day, everybody, whatever time of day it is, wherever you are around the world, and thanks for joining us for today's Fusion 360 Live. Got myself, Peter, and my good friend, also Peter, joining you today for some more generative design. So what we're going to be doing is continuing a kind of series we've been doing, taking you through the generative design setup of a component. We did have a bit of audio issues last time, so we might actually re-record that session and put something up on YouTube, just so that we've got a continuous series of videos that are going to take you through the setup of this component. What we're going to do is, again, just jump straight into Fusion 360 and keep going. So for those who are maybe joining us for the first time, what we've been doing is setting up the generative design study of the clutch pedal in this assembly here. So this is looking at an automotive component, and what we want to do is take an existing design and use generative design to reimagine what that could look like. So I'm just going to jump into my generative design workspace, and we can see the setup that we've done so far. So what we've done in the last 2 weeks is go through the setup for this component. And so the first thing that we did is we created this kind of strange geometry here, which we call our obstacle and preserve geometry, where our red regions are our obstacle keep out regions, where we're letting the algorithm know that there are areas of the model that we want to avoid. And the preserve geometry in green represents our regions that we want to keep in our design. So these represent the key parts of the model that are required for it to perform its core functionality. So in this case, for our clutch pedal, this is the pad that we're pushing our foot again, and then it's kind of rotating and connecting with the rest of our assembly about these points here. So what we did last week is we set up the load conditions and the manufacturing constraints for this component. So our load case for this component is going to consist of various forces pushing against the component, as well as so to represent the different ways that this design is going to be used. And then the other thing we set up were our manufacturing constraints. And we talked in a bit of detail about how some of these work. What these manufacturing constraints are going to do is that they're going to influence the generative algorithm to come up with designs that are particularly well suited for certain types of manufacturing processes. So we don't want to just come up with free-form exotic shapes that are going to be impossible to actually manufacture in reality. We want to have an understanding of what makes a good design for die casting or for CNC milling. And then lastly, we selected a few different materials for our generative design study to consider. And again, this is one of the nice things that we can do with generative design, is we can directly compare what is our design going to look like if we 3D printed this design using titanium versus if we CNC machined it out of aluminium. And obviously with one of those processes, we can come up with really very high performing shapes and components, but one of those processes is going to cost a lot more to manufacture. So as an engineer, this lets us make trade-off decisions about which design approach might best fit the design problem that we're trying to solve. So what we're going to do today is we're going to take a look at a study that I've set up already and run some results of. So this is exactly that same study that we've been setting up, and we've run a few different generative design studies. And when we run these different studies, we can change, for example, things like the objectives. So we spoke last week about how we give the algorithm a certain objective. So that might be to try and make a design that's as lightweight as possible, or it might be a design that we want to make as stiff as possible with a certain mass target. We can also do things like we spoke about how we've partnered with a company called A Priori to provide cost estimation of all the designs that generative design comes up with. And that cost estimation takes into account production volume as well as the manufacturing method and materials. So we've run a few studies with different production volumes just to show you how that affects the cost estimation that comes out the other side. So what we're going to be doing today is looking at how we can explore and compare these different designs that generative design has come up with against each other, make decisions about which design might best meet our needs, download the outcome that we like the most, and then if depending on how time goes, we might talk a bit about how we can make edits to these designs after they come out. So again, once we work our way through this bar along the top to set up our generative design study, and then we can press generate to generate our outcomes, and those are then going to generate simultaneously on the cloud. And we can then see those outcomes as they're generating, and once they're generating, by pressing this explore generative results button here. So what we've now got is we can see, if I scroll down, we can see these are all different solutions that the generative design algorithm has come up with for this clutch pedal. So these are all designs that generative design thinks might be a good idea for us. And then it's our job as a designer or engineer to compare these outcomes against each other, make decisions about, okay, which one of these designs do we like, which ones might we not like so much. So what I'm just going to show you is some of the tools that we've equipped you with in order to be able to make those kind of decisions. So just to kind of show you what's going on here, on the left of the screen here, these are a whole bunch of tools to basically filter between the different material or different designs that I've got. So the first one is called processing status, and this, as your outcomes are generating, they're going to start and they're going to be called processing, and there'll be a little loading bar, and that means that the design is generative design is still working on it and coming up with solutions. And then once that's finished, it'll either say converged or completed. We can also filter by different studies. So for example, we ran one design with a mass target of 0.2 kilograms, and we ran one study with a mass target of 0.3 kilograms. So I can isolate just my 0.2 kilogram study or just my 0.3 kilogram study, for example. And that just is a nice way to filter between studies. So if there's a study which I really I'm interested in those results, I can press this isolate button, but I can also turn off a study if I don't want it, and I can combine those tools together to kind of show the results that I'm really interested in. We'll talk about visual similarity in a little bit. But I want to draw your attention to these two tools here, which are really useful. So these let us filter by manufacturing method and material. And these are going to be extremely useful. So for example, if I isolate unrestricted outcomes, all I'm seeing here are designs where we haven't restricted generative design in any way, and it's just come up with completely freeform shapes. If I open up one of these designs, and we can open them just by double clicking them, we can see a preview of our design. You can see, so this unrestricted design is this really quite interesting free-form shape that is not going to be very easy to manufacture with a lot of traditional manufacturing methods. And that's the point, right? So this is generative design saying, okay, this is this theoretical shape, which isn't potentially very practical, but gives you an idea of the kind of shape that it wants to make. And if I just move myself a little bit out the way here, we can see on the right hand side of the screen here, we've got loads of really useful data about this component and how it performs. So I can see, for example, again, just to remind me that this was made with an unrestricted manufacturing method. We can see an estimate for the cost of this design. So my understanding is the unrestricted designs will assume that we're going to try and make it with additive manufacturing. And we can see, for example, the mass, the maximum stress in the model. And again, I've got a nice tool here to kind of see an idea of how that stress is distributed over the model. The factor of safety limit, and this is the objective that we set when we set up the generative design study, and then the actual factor of safety in this design. So based on the forces, this is telling us what the minimum factor of safety in this design is. So if I look at this kind of stress view here, again, this is just to give us a broad overview of where the max stress is in the design and how the stress distribution is across the design under the load conditions that we've described. So you can see that what we have is on the right, this stress reference, and it's just from high to low. And in the middle is this ideal stress. So what generative design is trying to do is it's trying to create an even stress distribution across our entire design. And it's trying to make sure that we haven't over-engineered our design, so it hasn't added too much material, but it's also trying to make sure that it hasn't got any points that are going to fail easily. So that's where it's trying to avoid regions of stress that are too high and regions of stress that are too low. So if we look at our design here, what we can see in blue quite clearly is our preserved geometry that we prescribed. So when we set up preserved geometry, that geometry, generative design is not allowed to take any material from that region. And so in this case, what it's suggesting to us is that actually that preserved geometry we created is potentially too thick, or there's too much material there, and it could actually get away with taking more material out of those regions, given the load conditions that we've described. So again, this is an important thing to think about when you create your preserved geometry, is the less material you describe for your preserved geometry, the more freedom the algorithm has to play around with the shape and optimize it. Okay, so that's an example of an unrestricted outcome.
So Pete, can I just butt in there?
Yeah, please do, yeah.
So someone was just asking about the difference between when your studies are converged or completed. And I just thought I'd ask you the question rather than do it in the chat.
Yeah, okay, that sounds good. So this can sometimes be a bit confusing to people, I think, the differentiation here. So basically, when we use generative design, we have an iterative design process. So if you can see on the bottom of the screen here, we've got this bar, and we can see the number 20, the number 30, and these represent the different iterations that generative design is going through to come up with the final solution. And what we're looking for is what we call convergence. So we've set an objective for generative design. So we've said, come up with a design that's as lightweight as possible while meeting my design objectives. And generative design with each iteration is making changes to the shape and then looking at that shape and comparing it with the objectives that we've set. And if we still want to take away more material, it's going to take material away from those regions. If we want to add material to regions, it's going to add material. And then it's going to move to the next iteration. So what we're looking for with these generative outcomes is what we call a converged result, where we're steadily working towards a final outcome. And once we reach that final outcomes, we're happy with that. We're not going to get much more success by continuing to iterate through. And that's what we then call a converged outcome. Now, there are times where our generative design algorithm it's finished its process, so it's not going to do any more processing on the design. It's not going to create new iterations. It's finished, but it might not have reached convergence, and that could be for all sorts of reasons. So, for example, we might have set an objective for generative design. So we might have said, I need to make sure that my factor of safety on my final design is at least 2. And our final design, generative design, might not have been able to reach that factor of safety. And our factor of safety might be less than the one we wanted. In which case, it's still finished its process. It's not going to do any more. So it will then say completed. So whenever you see a completed outcome, what that means is that for some reason, the design isn't fully converged. So that doesn't necessarily mean that your completed outcomes are wrong or there's anything necessarily wrong with them. But what I'd always recommend is if you see an outcome that is completed, and we can actually compare those against each other. So we can see these outcomes here are all converged, and then we're splitting the designs based on their status, their processing status. So if I look at this design here that says completed, and I think, okay, maybe I quite like the design that generative design has come up with. But if I look on my data, if I look on my information about this part here on the right, I can actually see that the minimum factor of safety of this design is actually less than the one that I specified. So whenever you see a completed outcome, my recommendation would just be have a little think about why it's completed, and there might be something about this design that means it hasn't met your design objectives, for example. So if you do see something like this, where the final design outcome is less than your factor of safety, one thing that you can try doing is drag this design outcome back a few iterations. If we pull this slider bar back like this, we can see the kind of step-by-step process that generative design took to come up with that final design. And it might well be that one of these earlier designs that generative design came up with actually did meet my factor of safety target. And so there's nothing to stop us taking and using one of these earlier iterations of the design instead of the final one. So every single design iteration that generative design comes up with is a fully downloadable outcome that I can access by downloading it. So let's say I actually really like this design here. There's nothing to stop me using this design. And for each iteration, we're going to give you the data on the right here that is representative of this specific iteration, not just the final design outcome. You'll notice we only give you the cost for the final outcome, so that's worth knowing. But yeah, so hopefully that's explained to you a little bit about maybe the difference between the converged and outcome. Okay, so we've been looking at some of these different designs. We've seen how we can use these filters on the left here to explore our different outcomes and filter them by manufacturing method and materials. Another really useful tool is this one here called the properties view. And what that's going to do is it's going to add that data that we were able to see when we double clicked this design and previewed it to this thumbnail view. And again, that can be really useful as well. So if I'm just scrolling through here, there's nothing at the moment that's telling me, for example, like which material these different designs are. Whereas if I click this properties view, I can quickly see which designs are made with aluminium or with titanium or steel. If I want to explore designs that way, then I can. And then the last thing that's really, really useful way to explore and compare different outcomes against each other is the scatter plot view. So what this is going to do is it's going to plot all of my designs that generative design has come up with on a graph. So each one of these little dots represents a design that generative design has come up with. And so if I hover over this, you can see a preview. If I click on that and then expand it, I can open up any one of these outcomes and take a closer look at the design. So we can also see that these dots are different colors. So I've got some green, blue, various colors of dots. And in this case, these dots are representative of the material. So, for example, I can see that my steel outcomes are kind of grouped around here. And on the bottom, on my x-axis, I'm showing mass. So as we move further to the right on my x-axis, we're increasing in mass. So if I compare these brown steel outcomes to this grouping here in blue, which is aluminium, I can see that my steel outcomes have a tendency to weigh more than my aluminium outcome, which is kind of what we'd expect to see. So this can give us some useful information about maybe which material might give us better or worse properties, or how those different material choices will affect my design. The other thing I can do is I can change these colors to represent different pieces of data. So if I change that to manufacturing method, then what we can see is, in this case, we've got in blue our milling outcomes, and then also in green and orange we've got our 5-axis milling outcomes, and then we've got our unrestricted designs, die casting, and additive. So this is where what I might want to do is change my setup. So if I change this y-axis, at the moment we're comparing stress against mass. So if I want like a really lightweight design that distributes the stress really well, then I'm going to be looking at a design that's kind of like in this bottom left-hand corner. So if I change this design, we can change it so that we're comparing these outcomes against the cost. We've got these two different options here. One is called piece part cost and one is called fully burdened cost. So my piece part cost is essentially the cost to manufacture a single design, not taking into account all the extra costs associated with manufacturing. And those costs are going to include things like, if I'm using a casting process, I'm going to have to manufacture or create some kind of tooling for that process. So the fully burdened cost is going to take into account all those extra costs associated with the manufacturing process, and it's essentially going to divide that cost evenly across the parts, and it's going to add that to the cost. If I compare these designs against fully burdened cost, then what we get are these kind of like these bars. So when we give you the cost estimate, what we give you is an upper and lower estimate for the cost. So if I click on this one here, it's got a very large upper and lower bound. We can see that we're estimating that this cost is going to be in the range of $3,000 and $1,000 to manufacture. And we can see from the manufacturing method that this is an additive manufacturing process. So again, what we can kind of see quite clearly is that my kind of pink additive outcomes have a tendency to be clustered quite high compared to my other outcome. The other interesting thing we'll see here is that in this kind of like turquoise color, we've got our die casting outcome. If I click on one of these die casting outcomes, we can see that the cost is quite high. And I believe what we can see is, so if we look at the production volume of this part here, we can see we're only producing 25 designs. We've run another study where we've got a different production volume. In this case, 2,500 designs. And what we'll see is that the cost per part for our casting process is significantly reduced. And this is, again, exactly what we'd expect to see. So as we're increasing the volume of our production, a manufacturing method like casting, where we've got an initial investment in things like tooling, is going to significantly reduce in cost per part as we increase our production volume. Okay, so these are some of the tools then that we've got to compare these different design outcomes against each other. Again, another useful thing to sometimes look at is maximum displacement against mass. And so what that's going to give us an idea of is how if I want a really lightweight but stiff component, then I can see the kind of designs that are being recommended to me. Again, if I maybe compare that against material, we can see that aluminium looks like it would be a good choice, potentially titanium as well, or even a casting process with magnesium. So these are just some of the tools that we have to kind of compare these outcomes against each other. So what we'll typically do at this stage is start to narrow down on our design objectives. So for example, if I've got a minimum factor of safety of say 3, I can filter out my designs so that I only have designs that are above a certain factor of safety. We can also filter them out based on mass. So for example, if I want to make sure that my design weighs less than 700 grams, then what we can do is we can then filter these outcomes against each other. So we've started to kind of narrow down maybe the design that we might quite like. What I can then do is I can compare multiple outcomes against one another. So okay, so if I open this design up here, I can press this compare outcome. And what that would let me do is visually compare this outcome here against a couple of other designs. If I open up a couple of those. We can see these designs in comparison with each other. And what I might decide is, this is where we need to think about what makes a good design for our component. So we want to think about, obviously, things like the cost. We've thought about things like the mechanical performance of my design, how much it weighs, things like this. We also want to consider things like aesthetics. So let's say I take this design here and I decide, okay, I really like this design. One of the tools that we've got is something called visual similarity. So what that's going to do, if I click this button here, maybe not that button there. If I go to this, hold on. Okay. If I go to this visual similarity button here, what we can see is that we've grouped some of these different designs into groups that we think are going to be visually similar. So we can see that we've analyzed these two designs, and generative design thinks that these two are going to be a kind of similar design outcome. So if we like a certain design, this can maybe help us choose a design that keeps that aesthetic that we like in that original design. Okay, so we can see in this case we've got a group here that has quite a few in it, and then we've got different designs. So the reason why, if you're wondering why I'm clicking on these and it's not showing for some of them, that's because I've got these filters on to make sure that I'm only seeing designs that are above a certain mass, below a certain mass, and above a certain factor of safety. Okay, so what I'm going to do is show you, once we've kind of decided on a design that we like and gone through this process of comparing designs against each other, we are kind of visualizing these different design outcomes at the moment in the cloud. So what we can then do is we can create the design using this create design from outcome. We spoke about this in our last session, but again, what I'd recommend is we've got these two different options to download outcomes. One's called mesh design from outcome and one's called design from outcome. My recommendation would be to use this create design from outcome. And that's just because it's quite a lot easier to go from this design to a mesh than to go backwards from this mesh to this design. So again, this is a design that I've created earlier by pressing this button. And once you've created a design, it gets added to its own group in this filter button here. So we've got this filter called design file, and we've got created from outcome and not created from outcome. So if I isolated created from outcome, that's just going to show me all the designs where I've downloaded them. And again, what we'll see is, if I move myself out of the way again, we can see this green like circle down here on iteration 20. So what that's telling me is that we downloaded iteration 20. If I'd created a design from an earlier iteration like 15, we would add this green icon to iteration 15. So again, this is just a nice way to visually see where we have downloaded that outcome from. Fantastic. So what we're going to do now is take a look at, once we've gone through this process, we've explored different design possibilities, looked at what generative design has come up with, and decided to which design we like the most. What we're going to do is show you how we can then edit that design and work with it inside of Fusion. So it's going to take a bit of time for, once we press design, create design from outcome, it's going to take a small amount of time to kind of process that, typically a few minutes. And then we're going to get this dialog box that says design ready, click to continue. So if I click that, it's going to let me open that design. And what it's going to do is create a new Fusion file, and it's going to bring this design into it. So we can see that here. So this is the design as it comes out of generative design. So it's looking very nice. We can see that this is a kind of solid body. So this outcome here was generated with the 2.5 axis constraints. And these designs, as we spoke about last week, create these kind of like tiered planes. So we have this really nice geometric shape that is quite easy to work with. So I'm going to hide, move people. So what we can see is that we've got this like timeline history bar here. Again, if you've done any design in Fusion, you should be really familiar with this history timeline. And we can see, if we drag this back, that what we've got is essentially like a series of sketches. And these sketches represent each layer of the design. And it's being built up kind of layer by layer to create this final shape. So what this means is I can go into any one of these shapes, and if I want to edit this design at all, I can kind of click and drag these spline points, and I'm going to create edits to my design. So I'm going to come back to this in a little bit. But the other thing I want to show you is, so we created this design in generative design. We could see our stress distribution across the model, and it was quite a kind of basic overview of where the total distribution of stresses were. So if I want a bit more information about how the stress is distributed across this design, we can use the simulation tools in Fusion 360. So what's going to happen is, if I drop down from my design workspace and go into simulation, it's going to come up with this dialog box here, and this is going to say, looks like the design was created with generative design. Do you want to use the setup information from generative design to create a new static stress study? If I press yes, And then what this is going to do is it's going to use the load cases that I set up to run my generative design study. It's automatically going to create those for my design here. That's going to include all my constraints and loads that I brought in. We can see we've got our 2 load cases, our force applied to this face here, and our constraints that we set up for our study for both of our load cases. And this is then ready to run. So if I press solve, and I can solve this on the cloud or locally, then that's going to generate, going to run a simulation. So this is, again, something I'd recommend when you're using generative design and you're trying to create, high performing components. I would always recommend to people, once you've downloaded the outcome, bring it back into generative design and run it through simulation. And that's just going to give you so much more information about how this performs under your load conditions beyond what you just get in generative design. The other thing that we can do in our simulation environment here is evaluate this part for things that we weren't considering when we set this up with generative design. So if you're familiar at all with the simulation environment, you'll know that we've got a whole bunch of different simulation types inside of the simulation environment. So we can compare things like we can determine the modal frequency of our design. We can examine things like thermal stress. So how does our part behave when it's under both thermal and structural loads simultaneously? We can examine things like structural buckling. And these are all things that weren't considered when we came up with this design in generative design. So if we know that our design is going to be going under some thermal stresses, or it's going to be used in an environment where the temperature is going to vary quite significantly, and we want to understand how this component is going to perform under those different conditions, what we'll definitely want to do is bring this into the simulation environment, understand how it performs in those conditions, and then typically what we'll then want to do is make some kind of edits to our design to account for those things that weren't taken into account when we created our initial generative outcome. So what we're doing in this case is we're using generative design to come up with, 80 to 90% of the design, and then we're able to come in and just make those small changes that we need to account for the things that we didn't account for in generative design, using just the design workspace. So again, if you're working with these 2.5 axis outcomes, I'd really encourage you to kind of explore making some of these edits to the design. I'll just tell you, like, one thing that I sometimes like to do when I'm editing these designs is we've got all these different sketch planes that are set up to create this design. So what we're doing is we're automatically recognizing where those sketch planes are kind of coincident with each other, and we're merging them together to create kind of smooth face. But what that means is if I edit, for example, one of the sketches in the middle, if I go in here and edit this sketch here, it's not necessarily going to change all those designs at the same time. That makes sense? So sometimes what I quite like to do is just edit this part a little bit if I'm wanting to make changes that are going to affect the whole model. You go back. So what we can do is if I go and create a new sketch on this top plane here, and I'm just going to use the project tool to project this geometry that we've got here from that design. And then I'm going to create a new body using that sketch. this. So I've now got two versions of my design. One of them is the original, and one of them is this kind of projected sketch like this. And this projected sketch is linked with that top face of the design. And that top face of the design is controlled by this sketch here. So now if I make changes to this sketch here, I bring that out like that. What we can see is for this new sketch that I've created, it's going to bring that down across the whole part of this design here. And in the same way, we've got these other components of my design here. And these are going to be connected with the bottom sketch. So again, what I can do is I can, if I hide this design here, create a new sketch on this plane here. Again, project. Body. Okay, so what I've done is kind of reconstruct this design a little bit. And what this is going to then mean is I can now make edits that are going to affect the whole design. So if I bring this shape in like this, for example, we can make that change. And when you're doing this, you have to be a bit careful. So this is whenever you have these linked sketches like this, this is kind of connecting from one thing to the next. And so we go to this body here. We need to make sure that our extrude recognizes that new profile. So as we change that profile, we just need to go back to the extrude tool that we used to generate this layer here. And now we've got a shape which we can edit in by, we can edit the entire design and face at once. So again, this really will depend on how you want to work with your design. We've got these kind of two options. One option is just to, as we said, take each layer of these sketches and edit one sketch at a time. And the other option is by using that project tool and projecting onto a new sketch, we can edit the entire design at once. But whatever you're doing, hopefully these designs are really easy to work with. Again, this design here is something where if I want to, for example, add detailing like chamfers to this design, that's all extremely easy to do because we've got this solid body that we can make, you know, the normal CAD edits that we'd expect to be able to do to it. So this is hopefully been a bit of an overview for exploring generative design outcomes and editing outcomes that we get outside of generative design. So don't know if we've got any comments or questions coming in, but now would be a great time for us to take a look at anything that was asked in the chat during that and discuss. What I will also say is that we're going to be continuing this series. So hopefully what we've done up to this point is explain in kind of a lot of detail each step of the generative design process, redesign this single component. So what we're going to continue to do is see how else we can use generative design to look at our assembly that we're working on, which is this automotive assembly, and continue to improve, reimagine components. But if anyone has any suggestions about maybe things we'd like to look at with generative design, please do continue to let us know what those could be. We'll have a think about how we could work some of those things into what we're going to be continuing to do in these live streams. So
yeah, I think that's all good.
Fantastic. Well, yeah, thanks again everybody for tuning in. Yeah, it's always a pleasure to have you here, and yeah, hope everyone's doing well. We'll catch you again soon.
Yeah, have a good week, everyone.